get this started. Okay, so today we are talking about literal equations. I'm hoping this will be a pretty quick lesson, but it is kind of a tough subject, so make sure you're paying good attention and writing stuff down as we go. A literal equation is an equation that has no numerical solution. Okay, something like this: a plus b equals c plus d. There's not a single number to be seen. Okay, that might not always be the case, but in this case it definitely is. And whenever you have an equation like this, you'll often be asked to solve or to manipulate the equation until we have one of the variables isolated. And we're going to start out real easy for the first one. I want you to solve for a. I want what a is equal to. So solve this equation for a. Well, as it happens, a actually is almost by itself already. There's only one thing stopping us from having a isolated, and that is this term here with a positive b, right? We've got a plus b, that's a positive value, and then we've got it equal to c plus d. So the way that we're going to isolate a, the way we get a by itself, is the same that we would do anytime I have any other situation where two terms are added together equal to another thing. And that is that I would do opposite processes. The opposite process of addition is subtraction. So I'm going to subtract. I'm going to subtract a b minus b, right? A equals c plus d minus b. And that right there is all we need. That is the literal solution for a for this equation. There's no number. We didn't have to do anything fancy. We just subtracted b, moved that term over, and we got our solution. Okay? Let's look at another couple of examples. Okay? Let's look at this one. This one's got a few numbers in it, a few more familiar sites, and it's kind of similar to the one we just did, but there's going to be an extra step, and you'll see that in a second. I want to solve for x. X is what I want here. Let me switch to blue. What are the things that are stopping x from being by itself? Well, there's this term here, right? And then there's this number here. And we're going to do two steps to get rid of those. Step one is going to look a lot like the last situation. Because once again, first thing we got to do is move those terms away that don't have an x. So we're going to subtract 3y. We're going to subtract 3y. And here it's going to cancel, and we're going to have 2x equals 4d minus 3y. Okay? So first step was to subtract that term out. By the way, if this were subtraction, we would then add, right? Whatever the symbol is there, we do the opposite of that. That's how we work this out. Then, we want to get x by itself, and the only thing left stopping us is this 2. Well, what's the operation there? Well, it's not addition subtraction. We don't have a plus sign or a minus. It's multiplication. Whenever I have a number next to the variable like that, that's multiplication. So we're going to do the opposite thing then. We're going to divide. We're going to divide by 2. And then what I do to one side, I've got to do to the entire other side. So I'm going to put the 2 down here, and x is going to be equal to 4d minus 3y all over 2. And again, that's not a very nice looking answer, but it is actually our solution here. Okay? What do I have next? Okay. Why don't we do one more? I haven't made this one up yet, so give me a second. Let's try 2x plus 3 equals 4x minus y. I don't like it. Hold on a second. So, for our next one, I've thrown in a wrinkle. Because it asks for us to solve for capital N, but what's the issue? Well, there's two n's, right? There's two n's. And that causes a problem for us. It causes a problem for us because it's not crazy easy to get just one n by itself. And it gets complicated because I've got a 3 and an a, and those aren't like things. I can't add 3 and a. So I can't just say, like, this would be a totally different story if it were 3n plus 4n, right? If I knew what a was, then I could just combine them, add them together, and I get 7n, or, you know, whatever the number would be. But I don't know what a is, so I can't do that. So I have to do something else. And that's something else that we're going to do. We're going to call it factoring, okay? We're going to spend more time with this later, but I want to make sure you're aware of it now, or at least recalling it now. I'm sure you've seen it before. It's something you're supposed to learn in Algebra 1, but we're gonna work with it now. We're gonna see an example of the way this works here. So when we have a situation like this, where I've got two things with the same variable, two terms, I should use the proper language, right? I'm a math teacher, use the proper term. When I have two terms next to each other like this, that can't be combined by addition, okay? But they do have some elements that are the same. Those things that are the same can be pulled out. I can take the n out of there, and I can take the n out of there. I can write it on the outside, so we've got this nice capital N here. And we're going to put parentheses. And these parentheses are going to contain everything that is left over after we remove that value, after we remove that n in this case. So the thing that's left over here is a 3, and the thing that's left over here is an a. And we leave all of that in parentheses, and we set it equal to 5. Now I've got n parentheses 3 plus a equals 5. That parentheses is implying for us that we need to multiply n times this package. But I don't want to do that. If I multiply n by this package, that'll take me right back to where I was. N times 3 and n times a. So instead of doing that distributive property, I'm going to choose to do the opposite thing. In this case, the opposite of multiplication is to divide. And this is a unique situation where I am dividing a package by that same package, right? This entire thing is dividing out, and that allows me to cancel on the left, and capital N is going to be equal to 5 over 3 plus a as our solution, whatever that ends up being, okay? So just to recap, we identified that we had two terms with one thing in them that was common. We identified that we couldn't add them because there was something stopping us, right? 3 and a are not like things, so we can't add them. So instead, we factored these things out. We took an n out of that, and we took an n out of that. We combined them and made a single n on the outside of the parentheses, and then on the inside we had 3 plus a. This is a statement of multiplication, n times 3 plus a. So to cancel the multiplication, we chose to divide. That's going to be equal to, as a result, n equals 5 over 3 plus a. Okay? Now, why do we care? Why do we care about any of this? Well, we care about this for this reason, okay? This is not a science class, so I'm not going to spend a lot of time talking about the ideal gas law and how it works. Just suffice it to say that this law exists. It is a law used to describe any kind of gas in our world. That includes oxygen, nitrogen, helium, any kind of gas. And the P stands for pressure, V stands for volume, T stands for temperature. N and R are a constant thing together for any given gas. Your chemistry teacher will probably explain all of this way better than I am doing now. But N and R are consistent for any gas. And when scientists looked at all of this, they said, hey, we can apply more pressure, we can, maybe squish the gas down, or we can let it loose, we can make less pressure that way. We can change the amount of space the gas takes up, we can affect its volume, and we can affect its temperature. But N and R, those things are consistent as long as the gas is the same gas. So as long as I'm comparing oxygen to oxygen, N and R are pretty much always going to give us the same value. There are ways we can control that. And as long as I'm comparing helium to helium, right, N and R should always give us the same solution. So the things that we can manipulate in a given experiment are pressure, volume, and temperature. Well, then they realized, after doing some thinking, after doing some manipulation, they realized, hey, what if I divided temperature on both sides of this equation? Now I've got PV over T equals NR. Hey, NR is always the same. Now I can make another equation. Because if PV over T is always going to be equal to the same value, then maybe a scientist could do a situation, an experiment where the pressure is really high. Let's say pressure is really high. And when that pressure is really high, that creates a situation for everything else. Maybe it increases the temperature, maybe it decreases the volume, whatever else. So that first situation where the pressure is really high has this one very specific case. But then maybe they lower the pressure all the way down. Maybe they bring it as far down as they can manage. Well, since PV over T is equal to NR, P with high pressure makes a resulting change to volume and temperature, and then P with low pressure should make a resulting change. And this manipulation of the equation allowed them to come up with a brand new set of laws. Charles' law, Boyle's law, and a few others that all were just extrapolations of, that's a big word, I'm sorry, they were reasonable conclusions that all came from this ideal gas law. And they figured it out after doing just one algebraic manipulation. They divided both sides by T and got a resulting formula. A formula that they were able to use for years and years and years to come. In fact, we still study these in our science books today. And this was just one example of how knowing good algebra rules allowed scientists to come up with very, very useful formulas. That's how all our formulas come. Someone had to sit down and think through the algebra rules and play with the equations until we got something useful. This is why we care about literal equations. Now, you may not use them much in day-to-day life, but they will make you much, much better at solving equations and manipulating them to get the solution that you want. And that's going to be really important in this class as we move forward. So hopefully this lecture wasn't crazy, confusing, or difficult. The homework tonight is going to be just more of this, more of the adding and subtracting, dividing some values, maybe a little bit of factoring. I'll probably have 1 or 2 questions that have some of that on there. But it's just going to be more of this moving things around and trying to find just one variable and getting it by itself. So don't memorize all of this, just understand this is why it matters. This is what it's used for. Okay? Thanks. Good luck on your homework. Looking forward to hearing from you guys soon.